The International Obfuscated C Code Contest, or IOCCC, is a competition for poorly written C code. Now I know what you're thinking, this is my time to shine. But not really, there are rules that you have to follow when producing this bad C code. The goal of the competition is to obfuscate the source code to make it as difficult to read as possible while still maintaining the core functionality. IOCCC programmers use a lot of clever tricks to produce the worst code you've ever read in your life in the coolest way possible. But hey, I'm a reverse engineer, so I deal with obfuscated code all day long. So how hard could it be to read? Huh? What is happening? Ugh, what are you doing? I don't even know what this is. Am I like losing my mind? Now I have a theory. The source code might be messy, but if we did something different and analyzed the compiled binary using some special tools, we might be able to produce some obfuscated code that is actually readable. The plan is to compile some of the winning obfuscated C submissions and use a popular open source reverse engineering tool by the NSA called Ghidra. Now this tool is a decompiler that will provide me an approximated view of the application code. First I want to test my gut feeling as a reverse engineer and see if I can guess which submissions Ghidra is going to process well versus not. Then I'll try running the application, see how close I was to getting the correct behavior, and also see how actually difficult it was to decipher. So let's start ranking. This one is Weaver, if you're looking at it in the IOCCC page. I do see a lot of calls to common library methods. So this is going to be very clear and easy to see inside of Ghidra. So my gut feeling, I'm going to give this like a rank maybe 4 out of difficulty. I don't think it's going to be too terribly difficult. Moving on to our next one, we've got the Kurdikov 3 source code submission right here. If you look at the top, these hashtag defines are going to be the macros, which are kind of like smart find and replace operations that are performed by the preprocessor on this code. You see that kind of got like this square obfuscation technique. I think I'm gonna give this one a 3, so not too difficult either. I feel like I'm getting overconfident here, but let's see. Next submission, Endo1. And this looks a little weird. Oh my goodness, this goes on for a really long time. I'm not seeing any strings, but I'm getting some weird vibes here. I feel like this is defining additional code. My spidey senses are tingling, and I'm gonna give this one a 7. Taking a look at Cable 1 submission, and it's not looking too spooky. We've got our macro definitions, we've got a lot of strings inside of here, and then we've got the indentation obfuscation. So I'm gonna rank this the same as the Kurdikov one and give this a 3. Going on to the How source code submission, this one looks like an absolute nightmare. I'm gonna give it an 8. Is Cable 2 even obfuscated? It doesn't really look like they did anything to it. I'm gonna give this one a solid 2. Whoa, Code Meow looks so sick. The nice tidbit here is that C doesn't actually care about the spacing inside of programs, so you can like literally do whatever spacing you want and it's all gonna work perfectly fine. I'm getting some questionable vibes from it. I think I'm gonna give this one a 6. Last one, looking at Kramer submission. This one really doesn't look too bad. Again, everyone's going for the square technique this year. I feel like this one's somewhere in the middle. I don't think I've done a 5 yet, so we're gonna give this one a solid 5. Now we have our final projected difficulty rankings, so let's go through and see how right my gut was. Or how wrong it was. So what we're gonna do is we're gonna open it up in Ghidra, do a little bit of analysis, then I'm gonna take an educated guess on what I think the functionality is, and then finally I'm going to execute the program to see whether my guess was right or not. Alright, this is the Weaver submission, and here as a reminder is the original obfuscated source code for this. So I originally gave this one a 4 out of 10 for difficulty. I didn't think it was going to be too terribly difficult. It seems relatively reasonable. We've got a lot of character arrays inside of this. So time for the moment of truth. Let's open this up inside of Ghidra and see if I was right. Alright, here it is. This doesn't look too terrible. We have all of our standard library calls inside of this. This is very nice. This is like never here when I'm reverse engineering code normally. This is so wonderful. Okay, I'm standing by my decision here. I don't think this looks too terribly bad. Let's take a moment. I'm gonna analyze this and we'll take a look at it marked up.
2 hours later.
So I've taken the time to analyze this application, renamed all the variables and methods inside of it so that we can understand better what's happening, and I think I've got a pretty good idea in general of what's going on. So this is probably playing some kind of sound in the background. I'm guessing some kind of music for this particular application, and at the same time it is running a graphic. So there's a couple main functions for generating the audio inside of this. You can see the associated code with this going through and playing that audio sample. And then if I continue on inside of the code and look towards the bottom, we're definitely doing some kind of animation at the same time simultaneously. So that's my prediction here. Animation with background sound. And that's probably as specific as I can get. I don't know exactly what animation it's going to be, but I think that's close enough. All right, let's see if I was correct. Oh my gosh. Oh my gosh. Okay. Well, I was right. Animation plus sound. Okay, this is a Rickroll. This is amazing. Never gonna let you down. Never gonna turn around and hurt you. I think those are the words. I can't believe I just got rickrolled by an IOCCC submission. That's wonderful. Well, I do have to say, technically I was right. It was an animation and there was even music in the background. So let's go over to the score. I was pretty right. I'm gonna give myself that one. And honestly, the code wasn't too terrible to analyze. It didn't take me that long to figure out what was going on. There were not too many components to it. It was mostly just two main ones, sound and animation. So I think I'm gonna stick with my 4 verdict. It really was not too bad. The worst part was that I got rickrolled from it. I should dock off points for that. Suddenly become a 0 in difficulty because you rickrolled me. All right, Kurdyakov 3 submission. And if you remember, this is what the original source code looked like. And I gave this a ranking of 3 for difficulty because I really didn't think it was going to be that challenging. I think that Ghidra's gonna do a pretty good job. Now let's open this up inside of Ghidra to view the approximated code in this application. And this is really not looking too terribly bad. It's an extremely short application. Not very much going on in this. I don't even see really external function calls. So I'm feeling pretty confident about my 3 verdict here. I think this is gonna be good.
3 agonizing hours later.
Oh my gosh, I've analyzed this application and I completely changed my mind on the difficulty level of this. So what they're actually doing is they're implementing an entire virtual machine inside of this application. And what that means is it has a list of bytecode that it's reading in the instructions from and a for loop that's dynamically deciding what instruction to execute based off of the input bytecode or opcodes. So it's a very complex entire virtual instruction set architecture built inside of this application. I can't believe they've done this. I cannot believe they have done this. Is that a vine?
I can't believe you've done this.
Anyway, if we look down here, this location actually defines an offset that has all of the bytecode that's going to be used for dynamically deciding what instruction to execute. So to summarize, I have absolutely no idea what this application does. Time for the moment of truth. Is it a Hello World application? Whoa, okay. Whoa. Oh my gosh. There's no way. It's Doom. Oh my gosh. Okay, how do I start? Okay, new game. Okay. Oh my gosh. It actually works. I can this is really playing Doom. Inside of all that, this is running inside of a virtual machine and the performance is like really good. I guess anything really can run Doom. Can I jump? No, I can't jump. Can I shoot? No, I can't shoot. Okay. So even so, I'm gonna give it credit here because I can move around and I can play Doom inside of here. This is absolutely insane. All right, this one, I don't know, this one should just win the overall competition. Okay, let's go through and score this one. Now, I had originally thought this was going to be really easy, so I gave this one a 3. boy was I incredibly wrong. I did not foresee that they had implemented an entire virtual machine in this, so for level of difficulty, since it completely stumped me and I had no idea, this one has to receive a final difficulty rating of 10. That one really took me by surprise. All right, Endo 1 submission. And if you remember, this is what the original code looked like, really long, and I gave this one a 7 out of 10 because I do think something weird is going on here, and it's like they're defining code inside of the defined code, and I'm honestly not sure what that's going to look like in Ghidra, if it's going to be able to fix it. So moment of truth here, let's pull this up inside of Ghidra and see. Oh, okay. Yeah. What am I looking at? It looks like they're defining extra code inside of the defined code. So from a reverse engineering perspective, this makes it basically impossible for me to mark up this application, because what am I going to do? I can't mark up code that isn't actually defined inside of the code, so this basically makes my job entirely impossible. Also looking at this is incredibly long, defined inside of one single function. What on earth are they doing? Taking a look at this, I don't think I can perform any additional analysis on this to get any extra behavior, so my projection for what this is doing is, I have no idea. So moment of truth, let's go over to the code and let's run this application and see what happens. I don't know what's gonna happen here. We're building an image. Ooh, well, this is interesting. This is doing some pixelation and image building over here. We're gonna get an 8x8 image. Oh, this is the tiniest image I've ever seen in my life. I had $1 for every pixel in this image. I would have like $8. Okay, we can build a better image than that. Okay, we're killing this process. This is gonna use up, oh my gosh, 128 by 128. If I can't even generate a 32 by 32, we're just gonna completely fail on that size. They do have some examples inside of here for larger images. So let's see what this is. Oh, this one's getting a little bit clearer. Oh, okay, this is like a little 3D ball. Oh, that's why it's so intensive, because it's actually rendering 3D images here. Ooh, we do have a 512. Let's see what, yes, there we go. Beautiful. I like how they didn't even add the 512 by 512 generation to the try script. They're like, yeah, nobody's gonna do that. All right, for the ranking time, I think, let's see, I gave this a 7 initially because I thought maybe there was a chance I'd be able to fix it in Ghidra, but there's really not any fixing it inside of Ghidra. So for the final ranking score, I think I'm gonna give this one a 9. Now, it's not a 10. I know you're thinking like, oh wow, I disagree, you couldn't get anything, so it has to be a 10. But I'm giving this a 9 because it did have code inside of Ghidra that I think I could probably write a script to like decrypt, but it would just take additional time, so that's why it's a 9 out of 10. All right, the Cable 1 submission. Now, as a reminder, here's what the source code looked like for the submission, and I gave this one a 3 because it has a lot of macros defined in it. I think this is going to be fairly reasonable for Ghidra to be able to reverse engineer. There's a lot going on here, but I think their main obfuscation technique was just the lack of spacing. So let's open this up in Ghidra and see if I was right. Here we go. This is it in Ghidra. Ooh, my confidence is waning. Whoa, all right, this, oh my goodness gracious, this goes on forever. Okay, this is interesting looking, but I do see that we have a couple of strings inside of here, so maybe this is going to be easier than I think. Magic time.
A little bit of time later.
All right, I did my analysis, and it actually turned out to be a little bit easier than I was expecting. I was intimidated at first by the really long functions inside of here, but there are quite a few different strings that help it start to make sense. Now, what this is doing, I believe, is actually running an entire LLM. So it's going to be loading a model, and then if we go down here, we can see we actually have somewhere inside of here the whole weights of the model loaded inside of memory here. So this is going to be running inference for the actual model. So I believe that we're going to be taking in a command line argument of probably like a prompt for the model and then running the model on that prompt. All right, moment of truth, but I actually already know that I'm pretty much correct because I had to cheat a little to figure out how to run this properly. But you can see we have a lot of different executables that were generated inside of here. The command to run this, if it gives you some idea, let's say describe yourself, and let's feed that to prog, which is the main program. So yes, welcome to Chat IOCCC. It is actually an entire LLM that is being loaded and executed. Okay, this is probably the slowest LLM in the world. Oh my gosh, can you imagine if the models actually ran this slow? You'd be waiting for your function to be generating and it'd be like, do I just write this myself? It might be faster. We have some other executables in here, and I'm gonna guess they're other personalities. We've got Eeyore. Eeyore, oh my gosh. We got Snoop Dogg. We got Rain Man. Let's talk to Eeyore a little. We've also got Linux. How do you have the personality of Linux? Yeah, that's just Eeyore. Oh, bother. Getting like childhood flashbacks right now. Oh, this is amazing. I can't believe we have all of these different options inside of here. I love this so much. Let's try describe yourself for Linux. What's this gonna do? It even gave me an emoji. Oh my gosh. Well, that doesn't seem like a Linux terminal that I know. Can it actually run commands? Okay, we're gonna find this out because this is crazy over here. Is it just hallucinating files right now? I think it's legit just making up files it thinks could exist inside of a directory. But let me tell you, Chat IOCCC, describe yourself is not a valid Linux command, so this is a terrible model. Okay, time to rank this. So I originally gave this one a 3 out of 10. Honestly, it was a little bit harder than I was expecting it to be. I'm probably going to raise this to maybe like a solid 5. I mean, it wasn't too terrible to understand what it did, but it did take me a lot of time to go through and fix the code, so I think it's an even 5. All right, this is the how submission, and as a reminder, here is the source code, and I did give this one an 8 out of 10 because I thought it was going to have just a million different functions inside of here. It just goes on and on forever, so each one of these inside of Ghidra is going to be a separate function. So moment of truth, let's open up Ghidra. Here we go. Oh, this is actually really short. Okay, but I do see a lot of functions in here. You might not think that these are function calls, but we do have a lot of obfuscated function calls inside of this. So this _y is actually a function with an obfuscated function name. So we have a lot of functionality that is being hidden inside of this. So let's analyze this.
30 minutes later.
All right, I analyzed this application and I went through and renamed all of the variables and functions based off of what I think their functionality is. And it looks a lot cleaner here. I will have to say it wasn't too bad for analysis. It had 2 main functions inside of this for handling a display on the screen, but the second one was the most important one for continuously handling input from the user. Now that wasn't exceptionally clear, so it did take me some extra time to find other functions since I couldn't find their references, but when I did, I actually found a lot of functions for handling different inputs from the user. So this is taking a file as an argument and then processing user inputs and then editing the file based off of that. So my hypothesis for what this is doing is some kind of file editing. Now for the actual functionality of this application, I did have to cheat a little bit to figure out what the key bindings were. So if I go over to the IOCCC page for this particular submission, you can see this is actually minivi, with a few modifications to some of the key bindings. One of the most popular modifications I would guess from people is that you can quit with Control-C, but it does have most of the regular Vim key bindings. So if we go over here, we can actually test this out. I'm going to do try, and that just creates a new file and loads that into our minivi. Any key, we're going to run that. Here we go. So we're actually editing the file, and I'm going to use the Vim key bindings over here. I can search. Let's search for the word char. We do next. Nice. So this is actually vi. So instead of doing :WQ or :Q bang, all we need to do It's Control-Z. This is probably the most popular feature that would be there if they implemented it. Going over to the ranking for this submission. Now, I originally gave this an 8, or a projected 8 for difficulty, just because I thought this was going to be super challenging to analyze. It was actually less challenging than I thought it was going to be, although I will have to say it was extremely long. So instead of giving it an 8, I'm probably going to give it more of a 6. It wasn't too terribly bad from an obfuscation standpoint, it was just very time consuming, and I was able to get exactly, well, almost exactly, what the functionality was. Let's go to the Cable 2 submission. Now here is the source code for this one, and when I saw this I was like, is this even obfuscated? Because it really doesn't look like it. So I gave this one a 2 out of 10 because I think this is going to be very easy, unless there's something like really weird there to surprise me. So moment of truth, let's open this up in Ghidra. Very simple, I am still sticking with my 2 projection. Do I even need to take the time to mark this up? I guess I will.
A few minutes later.
I marked this up, took me a couple minutes, really not that much time, and here is the output for this. So this is doing a little bit something funky inside of here that I didn't really notice. This should be actually printing out integers, and this is getting typecasted to a pointer to an integer, but this actually, when I take a look at the code, is getting a reference to strings inside of this. So if I take a look at this defined data segment right here, and I go over, it's a little bit small, but bear with me. This contains a lot of information about salmon and like a salmon dish or something like that. So I can take a look at this. They tried to hide the string here with Unicode, but it's really not too terrible if you see inside of Ghidra, like I said earlier. So if we go through, my projection for this is that this is doing something weird, and it's probably just printing out information about salmon. So that's my prediction. Time to see if I was right. Let's run the program. Season salmon fillets with olive oil, lemon juice, garlic, salt, and pepper. Then grill over medium heat for 4 to 6 minutes per side till flaky and cooked through. Yes, this is printing information about cooking with salmon. I was actually correct. So let's go back to our scoring here. I did give this one a 2 out of 10 because I thought this was going to be really easy, and genuinely it was, because I was able to find the string inside of the compiled application. But they did have a couple little tricks for string formatting inside of this, so I'm going to bump them up to a 3 because they did have something interesting inside of there, although it was still pretty easy. Alright, Code Meow submission. And here's the source code. One of the few for this year where we actually got a picture inside of the obfuscated source code. So I gave this one a 6 because it didn't really have that many macros declared at the top, and I thought it might turn into being something a little bit longer and harder to analyze. So let's go take a look at this in Ghidra. Alright, this is actually pretty short. This might be a little bit easier than I expected. Looks like we're just writing a lot to the console. Maybe writing some ASCII art or something? So let's take a moment and analyze this application.
Not too much later.
Alright, I've gone through and analyzed this application and renamed all the variables based off of their functionality, and it actually ended up being a little bit easier than I thought it was going to be, so I think my scoring for this is going to be a little bit high compared to what it actually was. So you can see they're definitely doing some kind of ASCII art animation based off of this. They're getting the height and width of the screen, and then they're writing a lot to the console. There's 2 main functions inside of this that are just doing the main animation calculations. So it looked a little bit scary with all of these numbers inside of the original source code, but it actually didn't end up being too terribly bad. Time to see what it does when it's actually executing. So I'm predicting that it's some kind of animated ASCII art on the screen. I can't be exactly sure what art it's going to be, but that's as close as I think I can get. So I'm gonna do /prog and let's execute. Whoa, this is so cute. Oh, it's a little tree. So it's like dynamically generating a tree on the console. So all of those characters we saw inside of there were part of the tree, and there's the final tree. That's cool. Now I did cheat a little bit and look at the profile for the submission on the IOCCC webpage, and it is generating a bonsai tree, to be completely specific. So going back to the obfuscated source code, I now appreciate it even more than I did previously because it's a little bit of the tree shape built into the code itself. And that's what's so exciting about these obfuscated code submissions. Now going on to the ranking here, I did rate this a little bit high. I think I gave this a 6 previously. I'm gonna rate this a little bit lower now because it was easier than I thought it was going to be, and I did say ASCII animation. I think that's pretty close to what it was doing. So I'm gonna take this down from a 6 to a fairly reasonable 3. Let's go on to the Kramer submission. Now this one I did give a 5 out of 10 for this obfuscated source code because it did have some macros defined in it, and those are just regular loops, so I thought it might be relatively reasonable. Also, it has comments inside of it, maybe kind of giving a clue that it's something related to numbers. This looks like some kind of foreshadowing right here. So I'm gonna stick by this decision right now. Let's open this up inside of Ghidra and see if I was right. Taking a look at this code. Whoa, okay, this is really long. Okay, questioning my life decisions at the moment. Oh my gosh. All right, let's take some time and analyze this application.
A lot of if statements later.
All right, I've taken the time to analyze this application, and it turned out to be a little bit easier than I was expecting it to be. Even though it's super long, it's mostly just a ton of different if statements. So maybe you could organize this to be a little bit cleaner, to be a single switch statement, but I have a good hypothesis about what this code is actually doing. And I was trying not to be biased because I did know what the original source code looked like, and that had some strings that kind of gave me some clues. But what we're doing here is we're parsing out the command line arguments and reading them as strings, and then performing some hashing of those strings and then some mathematical calculations. So what I think this is allowing us to do is perform mathematical calculations based off of input strings that are passed as command line arguments. Because at the very end, after it does some calculations, it just prints out a single long digit. So I think that's going to be our result. There's my hypothesis. Going over to the IOCCC page for this particular submission, I needed a little bit of a hint for how to actually run this application. So I took a look at it. You can see all of the information related to it, and it does give us some hints for how to try this. You can see it is doing some calculations based off of words that are being passed in as command line arguments, because we did see those command line arguments were being treated as character arrays. So let me try out this and see what it does. So I'm gonna do /prog, and let's do 2 plus 2. That was similar to one of the examples. And here we go, 4. That's actually very cool. So no wonder there were a million if statements inside of this. It's probably checking and hashing like every single string number that it can think of in order to produce the final output. I wonder if I can think of one that it doesn't account for. Let's do /prog 1 billion plus 5,000. Okay, that's looking pretty good. Gotta count the number of zeros here. Make sure it was right. 1, 2, 3, thousands, million. Yeah, okay. 1,000,005,000. That looks good. What can I think of that will stump it? Let's try /prog 1 quadrillion plus 8. It's gonna be wrong just because I can't spell. I think I spelled that right. That doesn't look right to me. Yeah, I think I stumped it. All right. Or maybe I spelled it wrong. That is a large possibility. I've got to Google this. How to spell quadrillion. I spelled it right. 10 to the 15th. Oh yeah, that is definitely not even close. I'm a genius. Let's go back over to our ranking. Now initially I gave this a 5. Honestly, I'm gonna give it I'm gonna give it the benefit of the doubt because it did show me a lot of information inside of the actual obfuscated source code, which I saw first. So I think I'm gonna leave this as a solid 5. It really wasn't too terrible to analyze, but I did have hints. Now let's move on to the final scores about what I projected the difficulty level in Ghidra would be versus what it actually seemed to be when I was hands-on reverse engineering the application. And honestly, most of my scores were pretty close to what I think they actually were. For Weaver and Kramer, I stand by my initial decision, and I think the difficulty level really matched there. There were only a couple where I was like really off. Let's see. Kurdyakov, that one, I thought it was going to be simple, and that one ended up being the entire virtual machine inside of the application. I really did not see that one coming, and that kind of gave me some troubles there, I'll say. I think one I'm most proud of is the Endo 1. I thought that was going to be a little bit difficult because I saw all of the extra code that was defined in there inside of macros, and it did end up being difficult. Actually even more difficult than I projected, but I did have a gut feeling that was going to give me some challenges. Now I highly encourage you to go back and check the IOCCC official webpage, especially if you would like to make a code submission for the next competition. They happen not yearly, but they happen every few years. Now the last one happened last year, so we'll see when the next one actually occurs. But this contains all of the past winning entries as well if you would like to run any of these applications. You can see you can go down to 2024, which is the one I was taking a look at in today's video, and this has all of the associated code so you can execute the applications just like I did. And if you want to dive deeper into the code of any of the submissions from a reverse engineering perspective, I guess it's just called reading the source code. Check out the IOCCC YouTube channel where they go in depth into some of the details and the techniques used inside of the code. So who do you think won that challenge? The obfuscated C code submitters or me with my reverse engineering tools? Leave your verdict in the comments below. Or also let me know if you disagree with any of my scoring decisions. So as always, thank you so much for watching everyone. Lori Wired out. Quality content.